people understand my intention.
Julia, I know you're upset. You just gotta breathe. We both just gotta breathe. Cow. I gotta go, Julia. We got cows. Another cow.
Actually, I think that was the same one.
Good morning, Royals. This is Mr. B from the Learning Lab up on the second floor. With the change of weather that's just happening, I thought it would be a great opportunity for us to talk about the weather patterns that we could see in the area, particularly vortices, plural version of vortex. We know them mostly as tornadoes or hurricanes or whirlpools. In Ohio, we're most familiar with tornadoes. Tornadoes are violently rotating columns of air that spins while in contact with both the surface of the earth and a cumulonimbus cloud, or in rare cases, the base of a cumulus cloud. A tornado tube is a great way to demonstrate what a tornado really does. A tornado tube is a piece of plastic that really just connects two 2-liter bottles of soda together. A tornado tube works very similarly to a tornado because the denser water is above the less dense air in these two 2-liter bottles. In order for the air to rise up and the water to fall, they have to change places. So when they do, they have to pass one another. It's kind of like when two people are moving opposite ways through a doorway, they have to move over so they can both fit through the space. The circular motion of the water allows the water to swirl around the outside of the bottle while the air travels up the center of the tube. Gravity forces the water down while the water forces the air up. In a real tornado, a cold and warm air front meet. Layers of the cold, dense air wind up on top of the warm, wet, less dense air. The cold air wants to go down and the warm air wants to rise. And so what happens is a vortex, also known as a tornado. You know I always say that science is everywhere, so get a chance, look around your home or the school, look at the way the water drains in your sink or your toilet. In the northern hemisphere where we're located, it will always drain counterclockwise. Then, when you get a moment, Google Coriolis force, and you'll understand why. Our next experiment, we're not going to use water as a vortices, but we're actually going to use fire. Fire! And fire makes a really cool demonstration. This is not an experiment that you should try at home. It is only suitable for the learning lab. For a better visual for this experiment, we're actually going to turn the lights off. This experiment requires cotton balls, a glass dish, lighter, rubbing alcohol, a spinning tray called a Lazy Susan, and a wire mesh basket. I'm going to safely light the cotton balls after I put a little bit of rubbing alcohol on them. And then I'm going to spin the basket as fast as I can. So what we discovered is faster that we spun the Lazy Susan, the more wind and air was being circulated through the waste paper basket, causing a virtual vortex. Ultimately, the faster that we would spin it, the higher the flame will go. Being that we're in the lab, I can only go so high. When you surround yourself with people that are positive and uplifting and send you positive energy, there's no limit how high you can go. How far, the sky is the limit. That's science.
Moo, may, moo. Yeah, yeah, yeah. Moo, may, moo. Wow, wow.